Be useful to see some practice based off of formula writing and naming. So here I've given you a series of metals and polyions, and what you have to do is figure out the oxidation numbers first, then we're going to write the formula and then name it. So if we look at this first element here, we have Zn. Zn is a single element, and so we look at the periodic table and we find it's in the D block and it has an oxidation number of +2. Now, if I look at Cn, these are both capitalized, and there's more than one element here, so that means it's a polyion. So I look at my polyion sheet and find it has an oxidation number of -1. So what we're going to do is do a drop and swap to write a formula. And then to name it, we're going to determine if Zn is considered a metal, a transition metal, or a nonmetal. Now in this case, I know it's located in the D block, but it has only one oxidation number possible, so I classify it as a metal. So I would call this zinc, because if we look at the first column in the nomenclature flowchart, you just write the name of the metal, and then you look up Cn on the polyion sheet, and you would see it's zinc cyanide. Now if we look at the next one, we have Al. Al is just a metal. And so we look it up, we find its oxidation number is +3. Br is a nonmetal, and its oxidation number is -1. So we're going to drop and swap. And then to name it, Al would be considered just a metal. So this would be aluminum, the name of the metal, and then you take your nonmetal and change the ending to "ide." Okay. So then we're going to continue on. We have Ra and MnO4. You'll find Ra is on the periodic table, and it has an oxidation number +2. MnO4 has more than one element, so that is a polyion. So we're going to go ahead and drop and swap. And so to name this, because there's only one oxidation number, we're going to go ahead and just write the name of the metal and the name of the polyion. Okay, so this is radium permanganate. It is a mouthful. Okay, so next one we have W with the oxidation number we have to figure out, but they told us it's a Roman numeral, so that means it's a +4. That's also indicated to me it's going to fall under the transition metal naming rules. NO2 is more than one element, so it's a polyion with an oxidation number of -1. So it's going to be W parentheses NO2, and then there's going to be 4 of them from that drop and swap. So naming, we know it's a transition metal. It means it has to have a Roman numeral. So this is going to be tungsten parentheses IV nitrite. Okay, so make sure it's ITE, because you'll find a difference of one letter will change your formula totally. Okay, so here we have another transition metal. I'm told the Roman numeral is +2. I know F is a -1. It's a nonmetal on the periodic table. I'm going to drop and swap. And then I could write the formula. I have to remember to use the Roman numeral. So it becomes platinum 2 fluoride. Okay, so the next one we have the NH4 ion, has a +1 charge. PO3 is a -3 charge. They're both polyions. Be careful when you write this formula. We will need parentheses on that first ammonia group. And then to name it, we're just reading both off the polyion sheet. And that is ammonium phosphite. Okay, and the last one of this style, we have a Roman numeral, so it's going to be +2. We have a polyatomic ion with a -1. This would be considered a transition metal. So this is COHCO32. So here we have cobalt 2, and this is bicarbonate. You could also see hydrogen carbonate listed on your sheet. Okay, let's do 2 more styles. So if you're given just the formula, you do need to figure out its name. And I highly recommend by going through and looking, is it a metal, a non-metal, or a transition metal? And that will help you to know where to go on the nomenclature flowchart. So Fe is considered a transition metal, which means I would have to use oxidation backwards to make sure I know its oxidation number. So I have 1 Fe plus 3 chlorine with a -1 charge equals 0. So Fe must be equal to +3. So here it becomes iron 3, and then chlorine becomes chloride. So we would use that second column in the nomenclature flowchart to figure that one out. Now, some of you might have figured out, well, that 3 came from here, from the drop and swap. You just have to be careful because sometimes things get reduced. So an example of that is here. If I have SNS2, I have 1 SN plus 2 sulfurs with an oxidation number -2, nothing in the upper right-hand corner. We find that SN is equal to +4. Now, if you just went from looking this way, you wouldn't have realized it has a +4 oxidation number. So that's why I suggest always double checking with oxidation numbers backwards to make sure you get the question correct. Okay, this next one we have phosphorus. Phosphorus is a nonmetal, so I should remember in my brain that means prefixes. You don't use mono for the first one. So it's phosphorus. Penta means 5, and chlorine becomes chloride. Okay, next one, K is a metal. So that becomes potassium. This is going to be the first column on your nomenclature flowchart. OH is a polyion. So that is hydroxide. Okay, here we have Pb. Pb is a transition metal. Okay, so we probably want to do oxidation numbers backwards to be safe. So we have 1 lead. Keep this as one thing. So we have 1 nitrate with a -1 charge from the polyion sheet. Nothing in the upper right-hand corner. We find that Pb is +2. So this would be lead 2 nitrate. Okay. And then the nitrate came from the polyion sheet. Okay, next one, P. Oh, that's a nonmetal. So I need prefixes. Di means 2. So this is diphosphorus. 3 is trichloride. So you only change the ides on the second one with those covalent bonding guys. Then at Li2O, we have a metal. So nothing special about lithium. And then oxygen becomes oxide. One thought that you might want to do is, you have that stair-step line, is you might want to color, let's say yellow, for all the metals that have only 1 oxidation number. Color your non-metals, let's say a different color, let's say blue, which means you're going to need prefixes. Now let's say you color elements with more than 1 oxidation number that are metals, the ones that you need Roman numerals for. Just so you know, it always is a positive ion if it has a Roman numeral. And by color coding your periodic table, it might help your brain with this idea here on naming. Okay, last but not least, we're going to look at, if you're given the formula, write the name. Now, if you are given the formula, I would suggest to decide if it's a metal or a non-metal first, because if it starts with a metal, you need to write the ions. So for calcium hydroxide, calcium has a symbol of Ca with a +2 oxidation number. Hydroxide is a polyion. So I'm going to write my 2 ions so I can drop and swap and write the formula correctly. So if I look at the next one, sulfur is a non-metal. So I just have 1 of those. Di means 2. So it becomes SOO2. Now this next one, we have ammonium. That is a non-metal. It is a special ion. So it's NH4 + 1 and NO3 - 1. Okay, so that's actually going to become quite a big set of letters. So that's NH4, NO3. Now here we have iron 3 sulfate. Iron is a metal, so it's +3. Sulfate is an SO4 with a -2. We're going to drop and swap. Then we also have a cobalt 2 for the next one. That's a metal. Sulfide, so -2. Drop and swap. And what happened on this one, drop and swap, you get CO2S2. They're both divisible by 2, so it becomes COS. And then last but not least, we have tribromine. If you start with a prefix, it makes it even more obvious. It's going to be a non-metal situation. So tri is 3, and then penta is 5. There is one thing I want you to watch out for, is details are going to matter in this unit. So for example, N-3 is nitride, NO3 to the -1 is a nitrate, and NO2 to the -1 is a nitrite. So we could also look at sulfur -2 is sulfide when naming. SO4 -2 is sulfate, and SO3 to the -2 is sulfite. So you'll notice it's very small differences between these. And I can do this for several combinations, so just be careful.